Hello there, I'm Thomas Hatsen, German-American pilot flying the Boeing 787-995 from Zurich International Airport. We're going to be overflying Zurich, Switzerland, Germany, then coming back to the Zurich International Airport runway 14 for an Lszh localizer. Landing so now in the cockpit for the pre-takeoff preparation of the quality wings Boeing 787-900 and a Microsoft Flight Simulator X. I'm going to start showing the cockpit instruments displays and the functions of the Boeing 787-900Z aircraft. I'm going to start with the primary flight display. That displays the airspeed indicated, the airspeed selected from the autopilot flight director system panel, the radio altitude above the ground level, the barometric altitude above the sea level, the target altitude selected from the autopilot flight director system panel, the barometric pressure of the outside atmosphere, the vertical rate of climb descent of the aircraft in 10,000 feet per minute, or the stiffness of the trigonometric angle in decreasing and climb and descent. We have also the artificial horizon with the attitude indicator, the pitch ladder decrease and the back angle decrease. The Lszh localizer, we have the Lszh localizer, the horizontal localizer, the vertical glide slope that is being received the radio frequency transmitted from the antenna, so the runway of the airports we use for takeoff and for landing. So you can see in the primary flight display the navigation aid guidance with the Lszh localizer crossbars also. So we have the Lszh, the Zurich International Airport in Switzerland, and the runway 14 Lszh localizer tuned for this flight. Also in the primary flight display we have the flight director crossbars for manual guidance of the aircraft and the autopilot crossbar for automatic guidance of the aircraft. We have also the flight mode annunciator with the autopilot and the autothrottle, vertical, later on vertical navigation modes, and the angle of attack of the aircraft as it flies. We have also the HSI, the horizontal situation indicator, with the integrated. You can see the flight plan, which is integrated into the horizontal situation indicator. Below, so we have to follow the purple or magenta line during the flight from takeoff over here using this runway. We're gonna climb through these waypoints and then come back for landing. So we have also the vertical profile of the navigation. We have the horizontal and vertical navigation display here. So we have the flight management computer, the thrust levers. Over here, the autopilot flight director system panel, the FS panel, the electronic flight instrument system, the ETS, the ACAS, electronic engine certification, the flight controls over here. So I will show you the flight controls also, how you use them in flight, how to use the side stick to input over here the yoke of the Boeing 787. So you can use the elevator for climb descent, also the ailerons and the spoilers, bang rolls over here, and the rudder pedals make joint turns in flight, nozzle steering the ground, and toe brakes. So we have also interconnected the tiller over here in the rudder pedals. So I will show you all these things, the flight controls, how we control the horizontal elevator here for climb and descent, make turns left and right over here, bang rolls left and right. So you can see here we have the side stick we use for climb and for descent over here. So you can see the side stick deflection is proportional to the yoke deflection. Make turns to the left, make turns to the right. Use the thrust levers also like this. So you can actuate the thrust forward and up. So we have the thrust levers here. You can see the thrust levers position here displayed in the ACAS and the indication control system display. When you move the thrust levers forward or aft like this. Also you see the side stick deflection is proportional to the yoke, so you can climb the aircraft, make descents. You can use only one, the elevator or the ailerons and the spoilers or the rudder pedal all together, coordinated flight. So you can see the captain and the first officer are interconnected in flight and move together unless you have some kind of failure. So you can make turns to the left, turns to the right, climbs and descents, and use all the rudder pedals. So this is how to use the flight controls. You can see also the outside view over here. Again, the elevator for climb and descent. You can see the elevator, climb and descent, better view, like this. Climb, descent. So this is the full deflection over here, like this. Also the rudder, left and right. And make turns left and make turns right. Full flight controls. So So you can see over here we have the primary flight display, as I told you, the indications, the navigation display. So I talked to you about the primary flight display. Also the autopilot flight director system panel, which changes the values, and you will see them displayed in the primary flight display. We have also the navigation display. The navigation display that displays the GPS position, the inertial reference position of the aircraft. We have the magnetic heading and track, the magnetic north pole and true north pole, and then magnetic variation depending on where we are in the world. We have the horizontal and vertical profile of the aircraft as it flies, so you can see the terrain around you. We have the weather and the terrain over here reflected, as you can see, with green, yellow and red, and the blue we have to see the lakes and the rivers. So you can see here the elevation of the aircraft above the ground right now. We are on the ground. So when we fly, you will see how far above the terrain we are. Also, we're gonna set the altitude here, the target altitude. You can see the flight plan here from takeoff. Cruise, we have to cruise through some waypoints here we have selected using the flight management computer. So we have the display in the navigation display, the terrain and weather reflection from the weather radar, other aircraft that fly around you using the transponder, the DSP and ADC transmitter receiver transmits our frequencies to other aircraft in the air traffic controller receives from other aircraft and can make calculations and display the other aircraft location, direction, altitude difference from our aircraft, and whether they climb or descend with respect to our aircraft, and whether they're closing in, the closing velocity, if they are going away from us. If they're coming in, like in an incoming collision, they will give us a warning. The TICA system, the traffic collision advisory system, to make an avoidance maneuver in flight. So you can see also the airport's name over here, the code name, the runway, We have the runway here, length, the direction we're gonna use for takeoff and for landing. So we are located in the Zurich International Airport, the Lszh 8, Zurich International runway 14. We're gonna use the runway 14 for takeoff and for landing. Zurich International Airport, the Lszh 8. So we have selected here flight management computer, created a flight plan. You can see the navigation display. Also we have the display of the workstations, the ADS, the NTBs, the waypoints, which are horizontal and vertical navigation fixes we can use for guidance in flight. The aircraft will have to transverse through some waypoints now because we have selected using the flight management computer. So we're gonna connect the LNAV with the VNAV function of the autopilot to flight director system panel and the auto throttle. It will give guidance to the autopilot flight director system panel to follow these waypoints. So we have all these things, also the workstations, ADFs and DPs. So this is most of things you can see in the navigation display. Also you can see here we have the air data computer in the overhead panel, so you can see many systems, electric, hydraulic, over here the APU, the batteries of the aircraft, the contactors, IDZ, the create charge generator, the fuel system over here, fuel tanks and fuel booster pumps, wing and engine guides, electronic engine control for the engines, with the auto start also over here, left and right engine, and we have the cabin pressurization. So I'm gonna show you most of the system. The air data computer is here. So they display all the air data. You see here the pitot start, you can the pitot dynamic when the aircraft climbs and descends, the angle of attack with the laser gyroscopes. We have 3 or 2 GPS receivers for every airline or aircraft. The inertial reference, the alignment of the aircraft with respect to the magnetic North Pole and the geographic North Pole and its GPS location. So it makes a lot of calculations, laser gyroscopic acceleration, deceleration, air data. So it's a very important instrument over here, air data computer and inertial reference system, the alignment. So I'm gonna show you also how created the flight plan. I input all the data of the aircraft for this flight. That includes the takeoff gross weight, the empty weight plus the passenger plus the cargo, where the cargo and the fuel are stored. We have the fuel on board, the taxi fuel, the reserve fuel and the trip fuel. Where the fuel is stored in the left and the right wing, how much is. Also in the center tank, it will calculate automatically the center of gravity of the aircraft for this flight. During the whole flight we're gonna burn fuel, so it will shift its center of gravity in flight, so it's recalculating every second. We have the aerodynamic chord position of the forward wings. Also this calculates the horizontal stabilizer, the horizontal tail trim stabilizer, switch position, so we can trim manually the horizontal tail here using this trim switch in the control wheel over here, or we can use the auto trim function. So you trim the horizontal tail of the aircraft like this, trim down, and like this way you trim up and this way you trim down, either direction, and you see how much you trim over here in the display. We have 4.25 and 4.25, so they are matching the selected with the flight management computer request for takeoff. So we have also here the alternate pitch trim. This way is pitch down the nose of the aircraft, and this way is nose up, this way, so we give a pitch up nose attitude in flight. The parking brakes here, as you can see. The horizontal trim stabilizer cutoff switch, so we have this switch, it cutoffs if you open. So we have over here the autopilot flight director system panel. If we have a failure of the L2 and R2 hydraulic system, we'll have to come down here and disconnect this from normal like this to cut off. So we won't have the auto trim function after that. We'll have only the manual trim through the control wheel over here, which is always variable. So you can trim up and trim down the horizontal tail of the aircraft like this during the whole flight. So it will balance the aircraft either nose up or nose down using the aerodynamic forces generated from the wings, from the airflow as we fly. So we have also other things to show you. You can see here the flaps and over here retract and extend. So you can extend as much as you wish or retract. The flaps position, we have the speed brakes also here, extend and retract. So you see the flaps over here, how many degrees, like right now it's 30 degrees. Also you can see the rudder trim, the landing gear, extend and retract. So you see the flaps are fully deployed right now. You can see also the speed brakes like this, extend and retract. So remembering we have the horizontal trim stabilizer here, horizontal tail of the aircraft over here. We have the elevator also that I saw you for climb descent instead of using the horizontal trim stabilizer. So we have here also, I will talk to you about the Newton's physics, about aerodynamics, aerospace engineering and aerodynamics, and Newton's physics and Bernoulli theory of fluids. So we'll derive some principles and equations we need for flying the aircraft, also for the air transport pilot license. So you can see here we have the surface area of the wings hold the aircraft weight as it flies. Also you can see we have the engine's thrust here, this component. We have the vertical axis through the longitudinal axis from the nose to the tail. So we can climb the aircraft using the elevator and make turns using the vertical tail. We have the deflection also from the ailerons and the spoilers. You have the lateral axis from wingtip to wingtip, longitudinal from nose to tail, vertical through the center of gravity, which transverses also the aerodynamic chord over here position, which is 23% of the Mach of the aerodynamic chord of the wings, is where the maximum aerodynamic lift occurs in the wings. Behind it's the center of pressure, and also we have where the stall will begin approximately in flight for an angle of attack that is given, and for an airspeed that changes depending on the attitude of the aircraft and whether we have flaps or no. And we have also here the altitude also of flight. We have the bottom surface of the wings, you can see it's more flat, and we have the flaps extended, so as we accelerate for takeoff, the airflow is moving much slower below the wings, so we have higher pressure, which pressurizes the wings up into the air with the weight, and that keeps the aircraft airborne. So we have also the top surface of the wings, you can see the airflow is moving much faster because we have higher curvature here using the Bernoulli theory of fluids again. From the bottom we have higher pressure, which pressurizes the aircraft up, and we have lower pressure, which sucks the aircraft up into the air. So this is the aerodynamics we need to know. I'll go now inside, I'll show you the rest of the systems. So we have, as I told you, the thrust levers. I will show you the thrust levers, the indications in the upper and lower ACAS. So we have the GNX engines, the General Electric engines. So we have one left wing, one right wing for symmetrical thrust and redundancy. They produce a lot of thrust. So each one contains a gearbox and the FADEX. The FADEX are the full-fledged electronic control computers that display and monitors all the engine functions using the upper and the lower ACAS, or the multifunction display. So you can see the N1, which is the low speed starter sub low pressure compressor and turbine of the turbofan filter engine, the exhaust gas temperature per engine. The N2, which is the high speed starter sub, the high pressure compressor and turbine of the turbofan turbocharged engine. The fuel flow parameters per 1000 kilograms or 1000 pounds, oil pressure, oil temperature, oil quantity, and the vibration of the N2 states of the engine. So you can see the thrust levers also here. Let's generate the thrust. You can see the indications here. So we have the N1, which is a low speed starter sub low pressure compression tube, and with the turbofan engine we can see the idle 20%, the maximum takeoff limit with green 100.4%. The exhaust gas temperature per engine 470 degrees. The N2 is the high speed starter after high pressure compression turbine of the turbofan engine. The fuel flow parameters per 1000 kilograms or thousands of pounds, 1500 pounds right now per hour in the idle position, oil pressure, oil temperature, oil quantity, and the vibration of the N2 stage of the engine. We have also the gross weight of the aircraft with the fuel, total fuel on board, saturated air temperature, fuel temperature right now. So we have over here the overhead panel. You can see the cabin pressurization. I will turn the switches from auto to manual. You will see what happens. They will display something over here. So we have the displays, as I told you, for the engines, the thrust position. We have cabin altitude right now, the display. Also some warnings. Cabin altitude auto, it gives us a warning outflow valve forward and outflow valve aft. So we have cabin altitude 1400 feet, rate of climb descent, differential pressure can go up to 7.8%, and the landing altitude 1470 feet. Auto for climb descent over here. So you're gonna see also here other interesting things inside the cockpit. So also the FAREX control other things, control the engine start and shut down, fuel flow to the engine's fuel metering unit. Also fuel metering unit, engine failures, fuel heat exchange sensors. We can heat the fuel all the time. We have to when we fly to avoid freezing the fuel at minus 37 degrees below zero. It will go freezing. And we fly in high altitudes like 30, 40, 50,000 feet. The temperature is much below that. It's recirculating automatically using the FAREX computers, the fuel storage electronic control computers, into the engine's components through the recirculation system, which ducts heat from the engine components and heats up the fuel. Also is doing the same thing for the oil. And we have the sensors for that. We have the fuel metering unit, the fuel flow to the engines. Also, as we fly the aircraft, also we have the outflow valves. I show you the outflow air. So we have outflow pressurizer from the 5th and 9th stage of the engine. Also from the bypass air from the front fan. So we use the outflow valves to regulate the pressure inside the engines. Also is done automatically using the FAREX computers. Automatically set the position of the outflow valves into a state that we have regulated pressure inside the engine. We have an overpressure or an underpressure. You can open or close the outflow valves into higher or low position to regulate the pressure inside the engine. Also we have duct air, pressurized duct air from the 5th and 9th stage, and the bleeder from the front fan, the bypass air. So we have pressurizer for cabin pressurization. When we climb and descend the air, we pressurize the cabin and regulate the oxygen. Wing and engine got the ice, air conditioning, and ventilation. Also for the hydraulic fluid tanks pressurization. So we have pressurizer coming from the engines or from the APU if we need a backup, or the armored turbine if we have a failure of an engine. So we have a pressurizer for the hydraulic fluid tanks over here for the hydraulic system. So you can see here when we move the flight controls up and down the rudder pedals. So all the flight controls using the wings, like the rudder, the elevator, the horizontal stabilizer, ailerons and spoilers, all need hydraulic power from the engines. And we pressurize some of this hydraulic fluid to increase the hydraulic pressure. We have also hydraulic pumps, engine driven and electrically driven. So we need for hydraulic for flight controls, aileron, spoilers, flaps, slots, speed brakes, elevator, rudder pedal, nose wheel string, the nose wheel of the aircraft, landing gear extend and retract, normal and alternate braking, toe brakes in the rudder pedals, horizontal trim stabilizers, thrust reversers for the engines, parking brakes, landing gear extend and retract. So all these need thrust reverse for the engines. All these need hydraulic fluid pressurization from the engines. Also, we climb the aircraft from the sea level all the way up to like 20, 30 or 40,000 feet above the sea, like 9,000, 10,000, 11,000, 12,000 meters above the sea. As we climb higher, the pressure of the air, the oxygen level and the density become less than half than that of the sea level. Also, the aircraft will be flying with an airspeed rate like 2 or 3 times faster than that of the sea level, so we have higher intake of air from the front fan for fuel mixer and combustion into the engine. Also, we have the temperature of the air is freezing, like minus 30, minus 40, minus 50, minus 60 degrees. So we have a different fuel mixer request every second. So this is adjusted also automatically every second as we fly, using the FAREX, the fuel mixer, also as we descend. So we don't have to regulate the fuel mixer like we do in the propeller aircraft all the time. So it's a good thing to have the FAREX installed into your engines. So after the FAREX, we're gonna see now other systems, the autopilot flight director system panel here. I'm gonna show you how to use it. So we have the autopilot over here, the airspeed. I will set the airspeed right now for the takeoff, auto throttle, left and right over here, on and off. So disarms and disarms the auto throttle. You can also disarm the auto throttle. Also from the thrust levers we have LNAV and VNAV here. We can turn off like this, disarm the modes. Also we use the flight director to the off position. We cannot use any mode no more. We have to turn on the flight director, very important, at least one of them, for flying the aircraft with the autopilot and the auto throttle. And then we can arm other modes, flight level change, auto throttle. Over here you can see the airspeed guidance, climb continuous, indicator airspeed Mach. So this is the flight management computer interconnected modes. The LNAV with VNAV. We have the autopilot disengage switch like this, the bang angle, select, also the heading select over here. So we'll select the heading, the runway heading we're gonna use for takeoff and for landing. 136 degrees altitude, climb altitude 35,000, 300, and the vertical speed. Also we have VOR localizer, auto approach for autoland, for vertical speed. So we have zeros like that. You can use a descent rate like this to descend the aircraft. Also we have the flight path angle, and we climb. I'm gonna use the other way, the plus sign. So airspeed guidance, heading guidance, vertical rate of climb, descent, and altitude over here. So you can see now everything changes here. The modes are displayed in the head-up display also. Over here in the primary flight display. You can see the airspeed indicated, the airspeed selected from the autopilot flight director system panel, the vertical rate of climb descent of the aircraft over here, in tens, hundreds and thousands feet per minute, the vertical rate of climb descent. We have also the barometric altitude above the sea level, the pitch slider degrees, like 2.5, 5, 7.5. So you can see how many degrees, 7.5 over here, 10, 12.5, 15, 17.5, 20 for pitch up or pitch down. Radio altitude above the ground level, the bank angle also as we turn, we can measure that. The target altitude 25,300. You can see also, as I told you, the flight plan over here. You can see, so also this is the FS panel. You can set the barometric altitude over here, the barometric pressure of the outside atmosphere. Select also the range here on the plan displays. So you can change the range over here. You will see a closer view of the plan. You will see the runway of the Zurich International Airport and the taxiway we have in front of us. So you can see the taxiway here and the runway, just like displayed in the original aircraft, and the GPS, how we are positioned. So we have a few more things to see. You can see the slope we have to climb, the flight plan, the terrain around you, the waypoints we have to cross through. Oh, we can change like this, yes. Also using these switches. The plan, the aircraft here position. You can see all the waypoints from takeoff over here. Using this runway, we're gonna take off and then climb and cruise through some waypoints. So I was talking about the waypoints. You can see the runway also here. How big it is, its length, and its direction. So we have. I will show you maybe. All the settings now are identical to the autopilot flight director system panel settings here. I will show you a little bit the flight plan here created using the control quadrant. So I show you that already. You know, this is the flight plan we have created. You can see I have inserted all the information through the initialize, the index here, identity, position. So we have the identity of the aircraft, position, performance over here. So we have the performance, gross weight, zero fuel weight plus fuel on board, gross weight, reserves, cruising altitude, cost index, minimum fuel temperature, cruising, center of gravity. We have the route, select the departure here, the origin and the destination, and the runway we use for takeoff and for landing. Departures and arrivals over here, select the departures from the airport over here, runway 14, then arrival. Then we have the creation of the flight plan using the seats, the southern instrument departure, waypoints and fixes, and the stars. So you can see we have to cruise through when we fly through these waypoints from takeoff. First waypoint, second, third, fourth, fifth. Here is 6,000 feet the airspeed and the altitude constraint. Then we have to climb to 25,000, 22,000 here. Nigra, Mati, Amity, Zui, Zits. Then we descend back to the airport. We have the south, the terminal arrival waypoints and fixes, runway 14 over here. So we have also initialized flap, center of gravity, trim. So we have the center of gravity and the trim position of the tail of the flaps 15 degrees, and the takeoff speeds V1, V rotate, and V2 for this gross weight. Other information, fix, hold, navigation radio. We can tune here. So we have many things to do with the flight management computer when we need. So I'll show you a few more things here using the aircraft. Right now we need over here. So I will show you the last thing I believe now is the overhead panel. We'll make the APU. I'll start the APU. I'll explain you the systems. Then we make an engine start demonstration. We have everything explained. So you can see also we have the thrust levers, the auto throttle disconnect switch over here, the thrust reverser. Pull up and you have the thrust reverser engaged over here. So you can see reverse thrust and you see the blocker doors here open in the engines. So the blocker doors open and reverse the flow of the air to slow down the aircraft in reject takeoff, for instance. So we have the fuel control, the left and the right engine here, the takeoff go round switch, auto throttle disconnect, flaps position, as I told you, speed brakes, external retract, fuel control left and right engine, cut off switch, fire extinguishers left and right engine, pull out and switch, transporter, radio and management panel, rudder, trim over here, a few more things, landing gear, extend and retract, alternate gear, auto brakes here. So we have the standby also instrument, the mouse pad here for the cursor. So we shall go now in the overhead panel. We have the electric system here. We start the APU. So we're gonna make an engine start demonstration. The battery also, you can see APU generator, contactors, 120 200 volts, 400 Hz frequency, IDZ, the great generator from the left and right engine. You can disconnect. Primary flight control computers in the auto position. Heading reference and inertial reference system, IRS. Flight control computers. Flight control surfaces. So we have towing power, FT door power, emergency lights, passenger oxygen, window lights over here, rammer turbine. We have the hydraulic power. We can disconnect the primary, the demand hydraulic pumps. You have the electric as a backup right now, so you'll see the fault coming up. So we turn back to the on, then to the auto position. So you see over here it changes back to on. We have the contactors here for the electric power from the engines driving generators. So we have here is the lighting system, the windshield wipers, the wing and engine got the eyes here on our auto position. We have over here some other instruments, the cargo fire and the APU fire, electronic engine control, left and right engine, normal and alternate mode, electronic engine control computers, and the auto start also. We're gonna use the auto start to start the engines. Fuel jettison, we can dump some fuel here if we need. This and also nozzles, left and right wing fuel booster pumps, setter tanks, the balance and the crossfeed. We use the crossfeed to feed either engine with either tank or either pump when you have a failure. So we use crossfeed valve off and balance off. We can also balance the fuel using the crossfeed valve. So this is the air conditioning and ventilation, pressurizer from the engines and from the APU. Outflow valve, use the outflow valve, climb descend, when climb descend, and select landing altitude to pressurize the cabin. So we use in the auto position during the whole flight. We don't need to do anything, it's all automatic. So this is most of the things you need to know. We're gonna start, we need pressurizer and electric power when we're gonna shut down the engines. So I'll show you how to start the engines like this very quickly. We have one last thing remaining to do here. See here the displays in a digital format in the systems display. So we have here everything is in the overhead panel. We have the hydraulic quantity, pressurization of APU, rotations per minute, exhaust gas temperature, oil pressure. So this is the information about the APU. Oxygen liquid cooling. So this is the status. Now you're gonna see the engines over here, electric power. So we have the electric left and right IGZ, the great generator, generator drive contactor, the APU is running left and right. So we have also the load set IPU battery over here, and also the main battery 31 volts, and the average, how many amperes you have from the electric power. You have the hydraulics now. So you see all the diagrams using the overhead panel, electric, hydraulics, fuel system, and pressurized air. You will see here in the digital format display all the systems of the aircraft are working properly. So we have here where the hydraulic fluid goes, primary demand pumps, C1 and C2 electric, how much quantity of hydraulic fluid you have in its system, center, left and right, pressure 5100 psi, and the quantity of hydraulic fluid, set of valves, fuel. So we have the fuel on board, just like you see in the overhead panel, left and right wing fuel tank, center tank, low and high pressure fuel valves in left and right engine, open and feed both engines. Also we have the recirculation of the fuel to the engines and of the oil. So you can see here the minimum fuel temperature is minus 37 degrees, below which in flight would freeze. Right now it's 1 degree. So we recirculate the fuel from the left and the right wing to the engines and the center tank using the recirculation system, and also of the oil. So it ducts the heat from the engines and heat up the fuel and cool down the engine. So we have also the fuel booster pumps, left wing, right wing. How much fuel you have in the left and the right wing? 11,000 and 11,000 and 12,000 in the center tank. You can see the APU is fed from the left wing using this motor. Also the total fuel on board is the sum of all left and right wing and center tanks. So you can see the diagram again is the same, like over here. So this is the fuel system. Now we go in the air. You can see the pressurizer, the air conditioning here. Where is it coming? Left and right packs from the left and right engine or the APU, and from the APU to start the engines. The doors are closed over here, so the cabin can be pressurized. The gear, you can see the temperature of the brakes and the pressure of the tires, also the nozzle steering. Flight controls, you can see all the flight controls, left and right wing. Over here everything is working when you move the yoke or the rudder pedals like this. So you see the tail also of the aircraft down here. Everything is moving normally, just like you see in the outside. The elevator, the horizontal trim stabilizer. So we have this function to monitor the flight controls are working properly, like this. Before flight, we have the FS display, the maintenance, circuit breakers. So we have circuit breakers, also maintenance, automatic, digital format, checklist, last thing to do before flight, normal menu, what we have to do, all the procedures here per flight, before start, before taxi, takeoff, after takeoff, descent, approach, landing, shutdown. So we have also the resets and the communications to the air traffic control, navigation display again. So now we're gonna start the engine. I'm gonna shut down the engines, restart them, and then we're gonna make a complete flight. So stay with me. You're gonna see me flying the aircraft for takeoff, climb, cruises, and approach and landing after the restart engine process. So we're gonna shut down both engines, both fuel controlled here. For normal, you will see both engines going off like this. So you can see both engines are shutting down here, the indications are decreasing, and we're gonna have the outside view. So you see also the hydraulics are closing down the wings. So we go over here in the overhead panel and set both restart engine auto start left and right. You will see the yellow amber indications of the controls now in the overhead panel, because we have the engine start process. You will see many indications are in the amber, now many systems. So we have the auto start now, and then we go for flight. So the N2 is increasing above 22%. So you can see here we have more air pressure inside the engine, the left and right, only pressurizer. So now we can start both left and right fuel control over here. You will see the auto start will kick in. We're gonna have the auto start process, both left and right engine. In the auto start process you will see also many systems in the upper will go off from the warning indication, from the fusion. So the auto start keeps increasing the engine power. So we have 63% we have running both engines, as you can see, left and right dedication. So we can process for takeoff like this. We just need to set the flaps up to 15 degrees, advance the thrust levers, and take off using taxiing into the runway. First take the air traffic control clearance, and we taxi to the runway. So we're gonna use the tiller for the nose wheel steering like this. So we advance the thrust levers to full takeoff power, and we go. So we go for takeoff like this. Use some rudder pedals here whenever we need. So we have V1, we rotate the aircraft slightly. So we only need a few small inputs for the initial climb. As you can see, we can leave our hands off like this, and the aircraft keeps climbing up on its own. You don't need to hold any pressure. So we have the initial climb here. You can see the indications. We are 800 feet right now above the runway. Keep climbing up. So we have positive rate. Landing gear up like this as we keep climbing. So we are 1,600 feet above the ground. 1,800, 2,000. So we are 2,400 above the ground, 4,000 feet above the sea. The airspeed is 200 knots. The pitch altitude like 17 degrees. We need to pitch down a little bit the aircraft. And we climb with 3,000, 2,900 right now feet per minute. You can see the terrain around you and below you, the terrain level, how far above the ground we are. The indications of the engine here. Also we can use further away. You will see the terrain displayed with red, green and yellow. We have different elevation. So we're gonna use a close-up view for having also the flight one. So we're gonna have to make a turn in a couple of minutes. You can see the whole of Switzerland here as we fly. So So we need to pitch down the aircraft a little bit and start the turn now. Hope you like the view of the lakes here in the Switzerland. The lakes, very beautiful view. The Alps. So we have like 17 more minutes left for this flight. So you can see the airspeed, the stall speed here, the margin, the pitch attitude, the bank angle also, like this, and the rate of climb, the altitude we are right now. So now we have to make the other way turn, like this. Is also. You can see the indications of the flight plan here on the other display also, as we keep climbing. So perhaps retract the flaps to increase the airspeed of the aircraft. So you can see you can hold your hands off, you keep flying the aircraft like this when it's properly trimmed and has a lot of thrust. So we're gonna have a look around over here. You can see the Switzerland again. The lake here, we're gonna make a turn now. The France in this way. Also the Boeing 787. So we're gonna make a turn now. We have also the Germany in this way. So we're gonna make a turn to follow this line of the flight plan here, the purple line. So we have a look here in the cockpit, like this. So we have a beautiful view here, the Swiss Alps, my homeland here, the Germany in front of you with the Bayern Munich, the France in this side, also the galaxy, we have the galactic view here. So you like beautiful views, and the lake. And we have 12 more minutes, I believe, for flying the aircraft. You see all the indications are correct. Maybe we have to start going back in a couple of minutes. So you see the follow up of the flight line here, how we follow the lines. The flight director also, he was, we need a little bit turn to the left. So we have the stall speed we need to avoid here, the red line, the Mach speed. So I believe we need to start now turning back home. So we are over almost the lake here, as you can see. So we're gonna make the turn now. So we're turning back home. We have the lake here, beautiful view. On the Swiss Alps. I'm gonna cross through, you can see. Use also some right rudder for this turn to make it more and decrease a little bit the thrust levers, so we'll turn more sharply with less thrust from the engines, like we're skidding more easily in the turn. So you can see we follow again these lines, the flight line, and we need to keep climbing, advance the thrust levers again. So keep hand flying over here. And we have about 11 more minutes left for this flight. Decrease the flaps. Increase the rate of climb. Cross through 35,000 feet. Keep climbing up. We're gonna have the chemtrails in a couple of minutes. So we are 36,000 feet, 400, and we're gonna have chemtrails now over here. So here we have them, the chemtrails from the engine's vapors over here. Hope you like it. Very beautiful. And we are 28,000 feet. Very beautiful view. The lake behind us also. we need to start turning to the airport. We need to decrease the thrust for descent. 29,000 feet over here. And we have 7 more minutes left for this flight. Pitch down the aircraft and use some speed brakes also for descent. So we keep descending the aircraft. We have the France over here, the Swiss Alps, Germany, my homeland behind you with the Bayern Munich and the lake. So we keep descending. So we have another view, very nice, of the cockpit as we're going back to the airport. So very beautiful view of the cockpit again as we're descending. Follow the indications here in the display. The airspeed increases, max speed as we descend. You have to cross through these waypoints here. You can follow in the flight plan. Keep descending, and we have 4 more minutes left for the flight. So we need to enter the approach now as we're descending. Now we enter the approach. So we are approaching. Keep descending, as you can see. Use some left rudder also as we turn. And we have 3 more minutes left for the approach ladder over here. Landing gear down, some flaps. So we keep descending, increase the rate of descent for a while. Full flaps again. So we are in the approach for landing right now. We have the right altitude to increase the rate of descent. We have some side wing. You can see also the Lszh localizer. All the information we have in the displays is correct. So we need that to follow over here, align with the runway. There's a little bit less thrust right now as we are approaching for the landing. Idle thrust, align with the runway. Over here we have the flare and touchdown, beautiful touchdown. Parking brakes, align with the parking brakes and thrust reverse over here. Align with the rudder pedals, right rudder and some left rudder now. You can see we made a very beautiful landing over here. You can see the nose wheel here is perfectly safe. There is no breakage of any part of the nose wheel or the wheels behind. The aircraft is standing up the way it should be in its wheels, its nose wheel. So that was Thomas Hatsen, the German makeup alpha in the Boeing 787-900.